Let's take a look at example 2. Step 1 is to apply the distributive property. So I want to look for where I see parentheses and a factor in front of the parentheses. And I see that right here. So I'm going to go ahead and focus first on applying the distributive property and distributing the 2 to both terms. So I'll distribute the 2 to the 5a. So 2 times 5a. Then I'm going to be subtracting 2 times b. So I'm going to be distributing the 2 to the 1b. Then from here, I'm going to copy the rest of the problem. So right in front of this distributive property section, I have an addition sign and a 3ab. And just behind, I have an addition sign and then a negative 7a minus a negative 2b plus ab. And you'll notice I wrote this again like you'll see it on the EOG, where the subtraction sign is larger and in the middle, and then the negative symbol will be at the top like this. We have the addition sign in the middle and then the negative symbol at the top of the 7. So let's just start to get used to that so you're not thrown off when you get to the EOG. In the next step, we're still finishing the distributive property section, and we're going to be finding the product of 2 times 5a, which is 10a, and the product of 2 times 1b, which is 2b, and then I copy the rest of the problem. After I've applied the distributive property, it is time to change the subtraction to addition. I want everything separated by addition. So I'm going to keep this 10a. I'm going to change the subtraction to addition, and I'm going to change the positive 2b to a negative 2b. And then I'm copying the rest of the problem until I get to another place where I see subtraction. So I'm keeping this negative 7a, I'm changing the subtraction to addition, and then I'm changing the negative 2 to a positive 2b, or the negative 2b to a positive 2b. And now you will see that in between every single term, we have addition. Now that everything is separated by addition, I'm going to reorder using the commutative property of addition. Before I do that, I'm going to recognize my like terms. So I see at the very beginning 3ab. Let's see if I have any other terms that have an a and a b with a power of 1. I see one right there. I don't see any others. So let me choose a different color. And then I'm going to go ahead and put a box around 10a, and then that goes with negative 7a. Those are like terms because they have the same variable with the same exponent of 1. Even though you don't see it, the exponent is actually 1 for those. And then I see a negative 2b and a positive 2b. And now I'm going to reorder using my like terms to determine what I put together. So I'm going to put together 3ab plus, and this is actually 1ab. When you don't see a coefficient, the coefficient is 1. So I'm finished with those. And then I'm going to add 10a plus the negative 7a. I'm finished with those. And then I'm going to add the negative 2b plus the 2b plus the positive 2b. And then I'll move this up a little bit so I have more room. Change colors again. And I'm going to start combining by paying attention to the coefficients. Remember, the coefficient is the number being multiplied by the variables. So 3 plus 1 is 4, so I have 4ab plus, all right, I have a positive 10 and a negative 7. So if you think about your integer chips, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I have 1, 2, 3, 4, 5, 6, 7 negatives, I'm going to end up with 3 additional positives left over. So we have 3a, 3a, and then finally, negative 2b plus 2b is equal to 0b. These are actually opposites, they form a zero pair. And we wouldn't write 0b because 0 multiplied by b is just going to be 0. And then from there, 4ab plus 3a plus 0 is actually just equal to 4ab plus 3a, and we can just leave off the plus 0 part. So that just totally disappears. So my final answer to this problem is 4ab plus 3a, and there's nothing else we can do because these are not like terms. Even though they both have an a with a power of 1, this also has a variable b. So these two terms are not like terms, so that is the final answer.